Hello and welcome back to my channel. Today in this video we are going to discuss another past year paper from Cambridge International TSNE level mathematics, and it is the paper 1, that is pure mathematics 1 from May-June 2021, and it is 9709. The component is 1, 2. So let's start with question number 1. So here's the first question, A part. Express 16x square minus 24x plus 10 in the form of 4x plus a whole square plus b. So there are two ways. One way is to, like, if we can open this bracket and we can compare the coefficients. Otherwise, if we want to do it directly, it's like 16x square is there. So 16x square means 4x whole square. And if we want to make it as a square, completing square, so the second term, as we know, that a plus or a minus b whole square is a square minus 2ab plus b square. So a square we have 4x, a as 4x. So if we take 2 into 4x, why we are writing? Because we require 2 times a into b. So 2 times a into what to get for 24. So we know that 2 into 4 is 8, 8 6 are 24. So it is 24x, and then since it is b is 3, so we will take the 3 square so that we can get a minus b whole square. So these first 3 terms gives us 4x minus 3 whole square and plus 1 already here. And how we got this 3 square plus 1? Because we had 10 here, so we can make 10 as 9 plus 1, and 9 becomes 3 square. So plus 1 left alone. And that's why if we compare, we get it as a equals minus 3 and b equals 1. So the b part is, it is given that the equation 16x square minus 24x plus 10 equals k. Now they have included k in place of 0, where k is a constant, has exactly one root. Find the value of this root. So if it has exactly one root, and here we have the left hand side as 4x minus 3 whole square plus 1, then it means we can get the square root. If we get the square root as 0, then only we can get the one root. Otherwise, anything in the square root, any positive quantity, or of course no, it cannot be negative, any positive quantity will give us the root value other than 0. So we will not get exactly one root. So first of all, we will transfer this plus 1 to the other side. So we got 4x minus 3 square as k minus 1. So in order to get exactly one root, this k minus 1 has to be 0. That's then only we will get 4x minus 3 as plus minus 0. That is only one root. So for that, we can write k value as 1 from here. And then if we take the square root of 4x minus 3 whole square, we got 4x minus 3 equals 0, which we will solve and get x equals 3 by 4 as the root. So this is the only root for the equation when k equals 1, or we can say for this equation. And here's the second question, A part. The graph of y equals fx is transformed to the graph of y equals 2 times f of x minus 1. Describe fully the two single transformations which have been combined to give the resulting transformation. So from fx, how we got 2 times f of x minus 1, that is what we want in the two transformation. So here we can see fx, first of all, fx become f of x minus 1. So and then we multiplied by 2 and we got 2 times f of x minus 1. So from here we can see the first transformation is the translation, because it is in the plus or minus. We can understand in that way, if x is coming with x plus or minus, it is translation in horizontal axis, that is x minus 1. So it is, if f of x minus a, then it is translation by 1 0, because there is no vertical translation. And then if you multiply fx function by 2, it means it's a stretch in y direction by scale factor 2. So these are the two transformations have combined to give the resulting transformation. Now b part, the curve y equals sine 2x minus 5x is reflected in the y-axis and then stretched by a scale factor of 1 by 3 in the x direction. So again, we need to understand what are the reflection and stretching means. So if y equals fx and it got reflected in y-axis, it is y equals f of minus x. And then if it is stretched in the x direction with the scale factor 1 by 3, so if it is f of ax, then it is stretched in the scale in the x direction with the scale factor 1 by a. So since it is 1 by 3, so it is only minus 3. This minus came from here and it is simply like multiplied by 3, so that the scale factor will become 1 upon 3. So we are going to simply write this in the as an input in place of x to get the transform equation curve. So y becomes sine 2 because it was 2, and x become minus 3x minus 5 times minus 3x, again the input. So we got sine minus sine 6x, because sine minus theta is minus sine theta, so minus comes out, and this minus minus plus, and this becomes 15x. So y equals minus sine 6x plus 15x is the equation of the transformed curve. I hope it is clear. Let's do the next question. Here's the third question. The equation of the curve is y equals x minus 3 root x plus 1 plus 3 outside. The following points lie on the curve. Non-exact value are rounded to 4 decimal places. So the values are not exact, they are rounded to 4 decimal places. A is this, B is given like this, C is given this, D and E is this. So find K, giving your answer correct to 4 decimal places. So in K, K comes in point A, and A has x as 2 and K as y. So it means in this equation, since they lie on the curve, so we can simply put x value as 2 in this, and we'll get y value, and y value is corresponding to 2 is k. So it becomes k equals 2 minus 3 root 2 plus 1, because I simply substituted x in place x as 2 and plus 3 outside. So it becomes k equals minus 1 root 3 plus 3, or we can write 3 minus root 3. And since we are going to give your answer to 4 decimal places, so first of all you calculate is 1.26794 from the calculator and so on. So to 4 decimal places it is 1.2679, and that's the answer. And for the B part, find the gradient of AE, giving your answer correct to 4 decimal places. So from first part we have seen A is K value is 1.2679, so A coordinates become 2, 1.2679, and since we require the gradient of AE, so we'll take the difference, or we can say change in y upon change in x. So y2 means 3 minus y1 here, that is 1.2679 upon 3 minus 2. So 3 minus 2 is 1, so all we need to calculate is the numerator, and numerator become 1.73250 and so on, and that is 1.7321 till 4 decimal places. I hope it is clear. Let's discuss the last part. The gradient of BE, CE and DE. So E is a fixed point, and they are finding the gradient of BE, and then CE, then DE. Round to 4 decimal places are 1.9748, 1.9975, 1.9997 respectively. State, giving a reason for your answer, what the values of the 4 gradients suggest about the gradient of the curve at the point E. Gradient of the curve is defined in a manner like if you find the gradient of points joining, gradient of line joining the 2 points, different points. And if it tends to that point, means if it is closer, x value is getting closer to that point, E here in that case, then the gradient would be the required gradient of the line, gradient at that point. So A is this, and in all these points we can see from B, because we have given the gradient of B, C, D. B is 2.9, C x coordinate 2.99, D 2.999. So it's like we are getting closer to E, because E x coordinate is 3, and in all the cases it is 1.9748, again closer to 1.9975, again it is closer to 1.997 and all. So from here we can see the gradient at E would be exactly 2, because it is tending towards the 2. So the reason is as the x getting closer to 3, the gradient of the line joining those 2 points are closer to 2. That's why the gradient of E would be gradient of the curve at E is going to be 2. And here's the fourth question. The coefficient of x in the expansion of 4x plus 10 over x to the power 3 is b. The coefficient of 1 upon x in the coefficient in the expansion of 2x plus k over x squared power 5 is q. Given that p equals 6q, find the possible value of p. So as the condition is provided, we are going to find in that way. Since it is given that coefficient of x in this expansion, so we will expand it, not completely, till the place we get x. So if we open it, we can use the binomial expansion, or we can use the Pascal triangle in that case, because the power is 3. So it is 1, then 3, and then again it was going to be 3 and then 1. And first power is maximum, first of all 4x cubed, and then 4x squared, and then you include 1 power of the second term, that is b here, and here 10 over x. And if we simplify, this x will cancel with this x squared and we get x. So the coefficient from here can be directly seen, that is 3 from here, 4 square is 16, and then 10 here. So p, which is given, it is as p, so p become 480. From here we got p as 480. And then the second condition, coefficient of 1 upon x in the expansion of this. So we are going to expand it. Maybe it is not required to expand it completely, because we only need to find where is 1 upon x. So 2x plus k upon x to the power 5. I am going to use the Pascal triangle. We can use the binomial expansion as well. Pascal triangle coefficient is 1, and then 5, and then 10, and then again it was 10, and then 5, and 1. So here we can see that first power is 2x to the power 5, then 2x to the power 4, and then 2x to the power 3, and so on. It will reduce till 0, and another term kx to the power 1, and kx squared. It is not kx, it is kx squared. I will write it here, kx squared. So if it is kx squared, so now we will cancel. We'll see here in the third term, it is 10 into 2x cubed into kx squared whole square. So whole square will make it x power 4 in the denominator, which when we cancel this power 3, we will left with only x. So that would be the coefficient of 1 upon x. So from here we can directly calculate them in that case, and that is going to be 10 from here, 2 cube, that is 8, and here it is k square, and that is given as q. So q become 80k square. Now the next condition is p equals 6 times q. So if p equals 6 times q, then p is 480 equals 6 times 80k square. 680 is 480, so it is 1, so k square is 1, means k equals plus minus 1. So I believe it is fine. Let's do the next question. Here is the fifth question. The function f is defined by fx equals 2x squared plus 3 for x greater than or equals to 0, means x is including 0 as well. First part is find and simplify an expression for f f x. So it's a composite function of f. F f x we write by f of fx. So the input is fx itself, and from here fx is 2x squared plus 3. So again there is a function, it is going to be applied here. So function, what is the input? If input is x, then output is twice of the square of the input plus 3. Now in this case the input itself is 2x squared plus 3. So it is going to be twice of 2x squared plus 3 whole square plus 3. So we'll open it 2 times, and this is a square, 4x power 4, 2 times 2 into 3, 4 3 is 12, 12x square, and plus b square, that is 9, and plus 3 outside. Now when open it is 8x power 4, 24x square, and then 18 plus 3, and then we will simplify, we'll get 8x power 4, 24x square, and plus 21. That's the biquadratic equation, biquadratic function now, and that's the expression for f of fx. Now b part is again connected. Equation of f of x is 34x square plus 19. We need to solve it. So yes, we need to find the x values. So first of all, from the previous part we got f of fx as this, and this equals to 34x square plus 19 given. So we will combine them at one place. We will make an equation, and then it is 8x power 4, 24, and this 34 will come here. It is 24x square minus 34x. 21 is still here, and minus 19 makes it equals to 0. So it becomes 8x power 4 minus 10x square plus 2 equals 0. And we can see it is 2, 10, 8 all can be divided by 2. So we divide it, we get 4x power 4 minus 5x square plus 1 equals 0. Now we will factorize it. 4 into 1, 4. So it is, and the sum, so 4x power 4 minus 4x square minus x square plus 1. I split the middle term, and then we take the common from first two. We got 4x square common, x square minus 1 is left. From the last two, minus 1 only common, again x square minus 1. So x square minus 1 common, we are left with 4x square minus 1. So if we create them equals to 0, first one will give x square equals to 1, that is x equals plus minus 1. And the second one would be x square equals to 1 by 4, and then x equals plus minus 1 by 2. And since the x values for that was greater than or equals to 0, so the only solution would be x equals half and 1. Half from here and 1 from here. We'll not take the negative values here. That's the solution. Now here's the sixth question. Points A and B have coordinates 8, 3 and P, Q respectively. The equation of the perpendicular bisector of AB is y equals minus 2x plus 4. Find the values of P and Q. So since this is given that equation of perpendicular bisector of AB is y equals minus 2x plus 4, we can see the scenario here. A is this, B is let's say this point, and M, perpendicular bisector, will pass through the M midpoint, and this is the equation of perpendicular bisector. So we know the gradient of the line AB and the gradient of the line of perpendicular bisector has to be negative reciprocal of each other, or we can say if we multiply gradient of AB and gradient of this line, it has to be minus 1. So gradient of AB we can find by y2 minus y1 upon x2 minus x1, that is q minus 3 upon p minus 8, into gradient of this, since it is already in the form of y equals mx plus c, so gradient is given minus 2. So we multiply, then it is minus 1, we can cancel minus minus, now it is plus, and then cross multiplication. So we got 2 times q minus 3, 2q minus 6, and p minus 8. So from here we got p equals 2q plus 2. We can make it as equation number 1, because that is the first relation between p and q. Next condition is this M lies on the line y equals minus 2x plus 4, that is perpendicular bisector. So first of all, let's say M is the midpoint of AB. We can find the coordinates of M by formula a plus b divided by x1 plus x2 upon 2, y1 plus y2 upon 2, and it lies on y equals this, so it should satisfy these values of x and y should satisfy this equation. So we got q plus 3 upon 2 equals minus 2, because this is minus 2 times x is this in this case, and then plus 4, whatever is given here. Then it is 1 by 2 times q plus 3, and we can cancel these two 2's here, and then we multiply by minus, so minus p minus 8 and plus 4 as it is. So we simplify, we got minus p minus 4. So we will cross multiply by this 2 to the other side, and we got q plus 3 equals minus 2p minus 8, and we simplify q and plus 2p another side, plus 2p equals minus 11. Now from p equation number 1, we got p equals 2q plus 4. So we will substitute it here, and we got q plus 2 times 2q plus 2 equals minus 11. We simplify, we get 4q plus 4q plus 4, and then if we add it, simplify more, 4q plus q is 5q, and minus 11 minus 4, because this 4 will go that side, it will be minus 15, and q become minus 3. Since q equals minus 3, we have p as 2 times q plus 2, so p equals 2 times minus 3 plus 2, and that is going to be minus 6 plus 2, that is minus 4. So we got P and Q both values. I hope it is clear. Let's do the next part. Here's the seventh question. The point A has coordinates 1, 5 and the line L has gradient -2/3 and passes through A. A circle has center 5, 11 and radius √52. Show that L is the tangent to the circle L. So roughly I have drawn this graph. This A can be here as well because there are two tangents with the same gradient. So that's fine. Let's say this is the line AL and this is the point A1, 5 for example. Because we are going to prove that it is a tangent to the circle. So let's consider if A is here 1, 5 and C is given and this is √52. So this is the radius. If we need to prove that L is the gradient, it means the gradient of L and the gradient of AC negative reciprocal because they are perpendicular. So gradient of L into gradient of AC has to be -1 and then only L is a tangent at A. Because if it is not 90 degree, then we cannot say that it will intersect here. So LH is the left hand side, gradient of L is -2/3 given, and 5 - 11 upon 1 - 5, the gradient of AC, 5 - y2 - y1 upon x2 - x1, then we got -2/3 into 6/4, that both are minus got cancelled and 2 ones are 2, 2 twos are 4 and 3 ones are 2, 3 ones are 3, 3 twos are 6 and 2 got also cancelled and ultimately we got it as -1. So it means L is the tangent to the circle at A. And this doesn't mean that it is going to be a tangent unless and until we prove that A also lies on the circle. So we will find whether A lies on the circle or not because this is not given that this A lies on the circle. So we have to find the distance of AC. AC has to be same as the radius. So AC, we have both the equation. We are going to calculate x2 minus x1 whole square and then y2 minus y1 whole square. Let's say x1 that is 5 minus x2 that is 1 and then 11 minus 5, it becomes 4 square 16 plus 11 minus 5 6, square is 36. So we got this as 52, which is same as radius, and that's why we can say that L is the tangent. Is a tangent? No, is the tangent? Yeah, of course, because at A only one tangent is possible. So at A, this is the tangent because AC is same as the radius. Had it been a situation if we did not get whether A is lying on the circle or not, so suppose this is the gradient, this is the line, and we get the gradient. So of course, still the gradient is gradients are the negative reciprocal of each other. So we have to prove that AC, that is this distance, the distance of the point from the center, is same as the distance, same as the radius. Now here's the B part. Find the equation of the other circle of radius √52 for which L is also the tangent at A. So I have drawn the scenario here. We can see this is the line L and there are two circles. Since this is a tangent, so it will touch here at A, and since it is a tangent, then this is 90 degree. I will mark the angle. This is 90 degree and this is also 90 degree because it is a tangent to the other circle as well. So it means it should form a straight line. And if it is this is a circle and this is a tangent, so the point E has to be the midpoint. So let the center be HK of the next one. So in that case, equation of circle would be x minus h whole square plus y minus k whole square equals 52. If L is the tangent at A, then A is the midpoint of CO, which I have told you. So midpoint of CO, let's find x coordinate 5 plus h upon 2 has to be 1 and 11 plus 5 upon 2 has to be 1, the second y coordinate. So from here we got h equals -3. From here we solve, we get k equals -1 and hence the equation of circle becomes x plus 3 whole square y plus 1 whole square equals to 52, root of 52 square. So that is 52. That's the equation of circle. Now it should come in mind that it is 5 comma 11, it is 1 comma 5. It should not be in this way. So that's completely fine because it is a rough diagram. It's not the proper diagram. So this has to be somewhere here in this direction. So that's it for this video. I believe it was of some help. So let's meet again in the next video with the last few solutions. Till then, thank you so much.